Alright, Uranus and Neptune, these guys are interesting. So, Uranus was discovered by Herschel in 1781. He was basically looking through a telescope, like we do, and noticed that there's something moving, but it doesn't look like it's moving fast enough to be a planet. So, in true suck-up style, he said, hey, let's call it George's star, after King George. Well, once they determined that it actually was a planet, they said he had to kind of follow the naming system here, right? Jupiter, then Jupiter's father was Saturn, Saturn's father is Uranus. So that's how Uranus got its name, thankfully, instead of George's star. Now, you can't really see it if you just look at it. You really do need a telescope, and if you do get a telescope or binoculars even, you'll just see a green dot. Very exciting. It's a green dot. So we sent a satellite, because that's what we do, and the satellite went by. We're like, okay, the green dot's going to turn into something cool. I mean, like there's Jupiter that has bands and spots and just incredible stuff. There's Saturn that looks like a mini Jupiter. And then there's Uranus. What in the world is it going to have? It's a green dot. Even as we got closer, it's a green dot. There's no bands, there's no spots, there's no features. There's no nothing. It's like, woohoo! Okay. Now, what else was interesting about Uranus? It didn't fit its orbit. It wasn't behaving like we told it to. Kind of like every child ever. But it wasn't behaving the way it was supposed to according to Kepler and Newton's laws. So, you got two options. Either Kepler and Newton were wrong, or there's something reacting with it that is changing its orbit. So there's something pulling on it, right? So either Kepler and Newton are wrong, or there's something pulling on it. Well, of course, humans are never wrong, so we looked for something that was pulling on it. Ta-da! Neptune. John Adams and Urbain Le Verrier, and Le Verrier is actually a really famous name in math, they worked together. Well, actually they didn't work together. They worked in opposite labs against each other, race to the finish, to figure out what was pulling on Uranus. And one of them, I believe it was Adams, I'm not sure, got his letter to Gale like the day before the other guy. And Gale looked up at the sky because Adams said, what they said, it should be right here at this point. Point your telescope right there. And he did, and lo and behold, Neptune. So Neptune was found just by math, which is pretty darn cool. Alright, going back to Uranus. It's on its side. Yeah, so instead of like the equator pointing towards the sun, you got the North and the South Pole pointing towards the sun, which really makes for a strange year. 42 years of light, 42 years of dark. And you thought Alaska was bad, right? So now why is it on its side? The big question. Yeah, we don't know. Nope, don't know. We think, just like with the rest of astronomy, when you don't know, there was a collision. That's what happened. Something came along, knocked it over. That's that. Just stayed over. There's absolutely no evidence to prove that, but there's no evidence to prove any other theory. So, no idea. Alright, now what are the atmosphere made out of? Well, hydrogen and helium. Shocker. Right? That's what Jupiter and Saturn are made out of too. Now, there is one difference. Methane. Right? Yeah, Jupiter and Saturn have some methane, but Uranus and Neptune have 2 to 3% methane. Okay, they also have ammonium and some other stuff, but the methane is the big deal. The methane gives it the blue color, right? So Uranus is kind of a greeny blue dot. Neptune is blue, the other blue planet, like they like to call it sometimes. So methane actually absorbs the red light, only letting off the blue or the blue-green light. So the more methane you have, the more blue you're going to be. So Neptune has more methane, it's more blue. Okay, so Uranus, right? That's the green one that basically is just the green one. If you look at it through a different light, which you can see here, I believe this is infrared, yeah, there's stuff going on there. Right? I mean, look at those dots. You can also see the ring system it has, because they all have ring systems. So there's actually some things going on. There's actually clouds in there. There's haze, which is why we can't see anything. The winds are just, you know, a little quick, 200 to 500 kilometers per hour. That's fast. Now, Neptune. Neptune you have to look through a telescope. You can't even pretend to see it without one. And it looks like a blue dot. However, you can see these white things, right? Those are clouds. You can also see this dark thing over here, and I'll talk about that next. But almost everything we know about Neptune came from Voyager, from a satellite going by it. Discovered more bands, also discovered spots. Spots mean storms, right? So sometimes this can be called blue Jupiter, right? Bands, spots, that kind of thing.
The atmosphere on Neptune is warmer than that of Uranus, at least the upper atmosphere is. We think this is because of the internal heat of the planet leaking out into the atmosphere and then being trapped. What's nice about Neptune is that you can still see some of the features. You can see some clouds. We know they're not quite as dense, but we know the haze is a little bit thinner, which allows us to see the clouds. If you look here at the visible on picture A, you'll be able to see how we can definitely see clouds, we can see dots, we can see stuff going on or in the atmosphere of Neptune. The bottom pictures B are actually in the infrared, but you can still see that there's stuff going on.
Voyager 2 flew by Neptune, and he could actually see the clouds. They were white clouds. We think they're made out of methane. We think they're about 50 kilometers above the other clouds, which is why we can see them. They're a little bit higher. Now, the winds are just a little quick. 2,000 kilometers per hour. Just a bit quick. They're also backwards motion. Right, so they go kind of against the rotation of the planet. Why this is, why they're fast, why they're higher, everything like that is still unknown. Now, Neptune has the great dark spot. So, Jupiter has the great red spot. The great red spot is south of the equator, has a counterclockwise flow, just like the hurricanes up here, and basically are turbulent, they're hurricanes. Great dark spot is very similar to that. However, the great dark spot can disappear. And it started out in the southern hemisphere, just like the one on Jupiter, but it disappeared and reappeared in the northern hemisphere. So why it disappears, because again there's no land, so we're not entirely sure on why that happens, and then suddenly reappears in a different spot, we don't know. And this is the one of the few things that they cannot blame on a collision, because that won't really have an effect with the spots.